Okay, well, we're at 1:15. Hi, I'm Heather Hedden, and this is a two-part tutorial that I didn't quite make it to the end of the first part. I didn't, it's hard to divide it exactly at that right time. Whether you were in the first part or not, we had ended with an exercise, but we can think of it, if you're just joining, we can think of this as a warm-up exercise of coming up with alternative labels which are not necessarily synonyms. In a taxonomy, alternative labels are approximately synonymous concepts for approximately synonymous labels, names for concepts for the context of the taxonomy and the users and the content. So what would work in one taxonomy as an alternative label, not as another. So I'm going to have this right here now so I can view the chat if you want to put your answers. So there are two exercises here, 1A and 1B, of alternative labels for automobile industry and alternative labels for compensation. This would be for workers, employees, and we'll look at some of those, and then I'll move on to the regular part of the presentation. But I feel we kind of got left off on that. And so yeah, this you can just put in right now. Put it into the chat. We have two, and there was one earlier, I think. One had, yeah. So I'll give a few minutes for that. And we're not behind schedule, that this was left over from, as you can see, slide 87 from the first one. The second slide deck isn't as long anyway. I mean, I think we're on schedule for the rest for this session. All right. Well, let's look at the automobile industry, and you can what people have put into the chat. Car industry, yes, that's good. Auto industry, car manufacturers, automotive industry. What's interesting with automotive industry is that it's slightly broader. It's not just automobiles. It would include trucks, lorries, buses. And your alternative label should be roughly equivalent, possibly narrower, but not broader, because then it would be retrieving content beyond the scope of the concept. So that one is tricky because usually automotive industry refers to automobile industry. So okay. Passenger vehicle industry is fine. All right, and car business. Let's move on to the second one, compensation. If you want to throw some things into the chat for that. This was not as specific, I think. There's a little bit more room for variation here. Can keep adding some. I'll go back. There was one that was, I think, added a little earlier. Okay. Okay, remuneration, salary. Those are both good. Payment, that could be a little bit vague. You'd have to think of the context, but even within an organization, payments could be made for purchases as well. So that would be careful. Benefit, that's interesting because, yeah, actually, maybe put it in plural, benefits, because we consider employee benefits as part of a compensation package, and narrower is accepted. It might be better to qualify that as employee benefits and not just benefits, because there are other uses of the word benefits out there. Income, well, that's perspective, of course. From the individual, they think of it as income. From an organization, an employer, income means something very different. So there, the context would make a big difference. And since our taxonomies are, you could qualify it maybe. But yeah, from the perspective, and I think compensation, we might think of it more of the employer side and human resources side. I think we'd have to be a little careful about using income. Salary is good. Incentive, again, might need to be qualified. Bonus benefits, that's good. Adding the word bonus, I think, makes it more clear. Okay, well, that's good. Now I will, let's see, I'm going to move on to present, let's see here. I like to present the full, so I'm going to stop sharing and start sharing again. Sorry, excuse me about that. Okay, am I sharing my title slide nice and big? Yes? No?
Looking good.
Looking good. Okay. Yeah, I think I'm doing slides in Google Slides, not PowerPoint, so it doesn't quite fit into the container of this platform. So you have a nice big view, and then I don't see the questions that are going into chat. That's why I switched that to see at that point. So if you have questions, I mean, I will pause and read them occasionally at sections, but we've set it now that you can speak. We didn't have that in the first half, but if you're not speaking, you please leave it on mute. But if you want to ask a question, I will maybe pause and say if there are any questions and do it more like that. Although we will have another exercise to throw things into the chat, and I'll have to just switch out then. So I do have a title slide, and I have this title slide about me, but this is for part 2 now. The previous part we were looking at taxonomies and control vocabulary types, and then with taxonomies we got into the concepts and their labels. So that was an exercise on the labels for taxonomies or thesauri. So the next section immediately following is the relationships, and then we'll also talk about governance, a little bit on faceted taxonomy design, and then we come back to ontologies again, because I had said that ontology is, well, it can be combined with a taxonomy. You can also define ontology as an upper level semantic model of the semantic relations and classes and attribute types, and then apply it and extend it with a taxonomy. Okay, so, and I say taxonomy / thesaurus relationships because there's sort of a continuum between taxonomies and thesauri, especially in how they are managed in taxonomy thesaurus management tools. And they're managed together in the same way, and it's more of a design issue, how extensive you'll make your hierarchies, what relationships you'll use, whether it trends more towards a taxonomy and more towards a thesaurus, and as I explained in my first section, why you would tend towards one or the other. All right, so relationships in taxonomies or thesauri. I talked about the SKOS model, that they're hierarchical, broader concept, narrower concept, as reciprocal, and the associative, which is related concept. Now, the traditional thesaurus model will call these broader term, narrower term, and related terms, because traditional thesauri focus on terms, not concepts. But it doesn't matter. It's the same in this sense. What's different is that thesauri traditionally will treat the alternative labels as a relationship too, but we're not doing that anymore. Now you know the principles of alternative relationships. Additionally, in SKOS, there are relationships between concepts in different concept schemes or different taxonomies. They don't even have to be, one could be, linked to one even somewhere else on a different organization, a different URI. And these are exact matching, close matching, broader matching, narrower matching, and related matching, which is a larger set. So of course, exact and close are really to link what's pretty equivalent, and the broader, narrow, related areas if you really want to extend. So this is a different use case, which one of these you would be using, if at all. Okay, and the summary of the SKOS types I had showed. So now you can see over on the right here that what they call them semantic relations, and I think that's a misnomer because they're not very semantic compared to what you can have in an ontology and the mapping one. This is what I'm going to focus on in this next section. Okay, the broader, narrower, and related. The hierarchical relationship. It's reciprocal. I mean, it goes in two directions, but it's asymmetrical, so it's different. One direction is broader, one direction is narrower. And the way to think of it is that the broader includes the narrower. So some of the broader is narrower and all of the narrower is in the broader. So if you have fruits and oranges, yes, and oranges are narrower to fruits. Fruits are broader to oranges. Some fruits are oranges and all oranges are fruits. And then, so fruits has narrower concept. Oranges has broader concept for fruits. The relationship name, when it says broader concept, narrow concept, or broader term, narrower term, it's the name of the relationship. It's not the name of the concept. So some people get confused about that. I say, okay, oranges is a narrower term. Well, it depends. It's only narrower in the context of fruits. It's broader in the context of specific kinds of oranges, like Valencia oranges. Then oranges is the broader. So that's why I put the word has in here. Has narrower concept, has broader term. Just always put that in there, and then you got it. Okay. According to thesaurus standards, there are 3 subtypes. The most common is this generic specific, where you can think of it's a kind of, or is a. Generic instance, where it's a named entity instance, and whole part. And here I have all kinds just for one, museums. So the generic is a museum. The narrow concept would be art museum. Art museums are a kind of museums. Narrow concept generic instance would be a name of a specific one, here, Guggenheim Museum. And narrower concept of a whole part would be a part of museum. The museum gift shops are parts of museums. If you are familiar with ontologies, I think maybe some of you are, this is not how it works in an ontology, because ontology has a hierarchy of classes and subclasses. They are only of the first, generic specific is a kind, sub-kind. The instances are considered something different. They're not even considered a hierarchy. The ontologies will consider individuals, and then they will be linked to their class, but they are not a sub-hierarchy of it. And the concept of whole part doesn't really exist in ontologies. So do keep this in mind, that you can't just convert a hierarchical taxonomy into bring it into Protégé as an ontology management tool and think it's going to treat it all beautifully, because things will not go where they should. Okay. All right, look at it a little more closely. The generic specific, it's like, having a category or subcategories or more specific types. And just think of it is a, but of course we usually use plural for countable nouns. So are a kind of, the narrower is a kind of broader. So dogs, I'm putting it, has narrow concept. Puppies, financial services has narrow concept. Investment services, Romance languages has narrow concept. Italian language. So this is comparable to an ontology class subclass. The instance is a unique name individual or a common noun, proper noun, but it's also when you word it, it's still like saying is a, like Samsung Galaxy is a smartphone, so it has narrow concept, or Tiger Woods is a golfer, so that's a narrow concept. Thanksgiving is we just had that holiday in the US, that's why I put it there when I was creating it. But this is, in ontology, is comparable to an ontology class plus individual. And actually, in an ontology class, I think Samsung Galaxy would not be an individual, because it's not it's a brand. It's not a unique one. I mean, all right, I got one here, right? This is mine. Mine is the only individual one. Right? Every other, there are many of them out there. Okay, and then the whole part is a concept or entity and its subparts or subentities. So instead of is a, it's in. So this works well for geography. I'm here in Massachusetts. It's in New England. That's why I put that example here, but that's very common. Yeah, it's an anatomy, right? That stomach is in the gastrointestinal system, and definitely for organizations, subentities like UN. But it must be an integral part that cannot be taken out, or is not intended to be taken out. So an example here would be bed and bedroom. It's not, even though the bed is in the bedroom, the relationship between the concepts of bed and bedroom is not hierarchical. It's associative. The bed belongs in the bedroom, is usually found in the bedroom, but is not part of it, because the bed might be in a different room. It might be in some other spare multi-purpose room. It might be in a hybrid office room. It might be in the store. It might be in the truck. It could be anywhere. So that's what it. And this interesting example, computers and motherboards. Well, integral and cannot be taken out. Well, yeah, you can take the motherboard out. Well, are you going to? Well, that depends. So that is it depends. And if the taxonomy has to do with computer products, it would not be hierarchical, because you can go and buy your, order online and buy your individual components of a computer. But if the taxonomy was one in instructing an educational one on a course on introduction to computers to college freshmen, undergraduates, and I have created such a taxonomy, they're not going to be taking it out. They just like, these are the basic parts of a computer, and this is what, that would be okay in a hierarchy. So that's why that one, it varies. So there's usually some variation. Polyhierarchy means a concept may have more than one broader concept. So the usual trend is to have broader and then multiple narrower and multiple, trees that way, not this other way. But sometimes it goes in the other direction. But it has to follow the same rule that all of a narrower is included in the broader, and is or kind of. So online banking, is it a kind of banking? Yes. Is it a kind of online service? Yes. So then it can be both, and that would be okay. It's a polyhierarchy. The purpose is to provide multiple different top-down browsable navigation paths to different users who would think about it differently. But again, the whole, as any other purpose of hierarchical relationships, it provides context for tagging and auto-tagging as well. And the idea that banking can retrieve everything tagged with online banking, and online services can retrieve everything tagged with online banking. But there are some issues that be cautious about. Some content management systems don't support it. SharePoint doesn't support it within a term set, but across term sets, which doesn't make sense. It really should be within a term set. And if polyhierarchies become too extensive, then you kind of lose. That's why I drew this diagram here, all these polyhierarchies. The familiar tree structure is lost, and users don't see a logical hierarchy, which that's the whole point, is to have some logic, and they spend too much time clicking all over the place. Okay, so now we have another exercise, and I will switch out of this presentation mode so I can see what people put in the chat. So this would work the same way that it did for that first warm-up exercise on alternative labels. We'll do one and then the other one. And this is kind of a double exercise where you can suggest both a broader concept and narrower concepts. If you are, yeah, I mean, you can put, when you submit something into chat, you can put, I want to keep the teachers and the hospital separate, but let's do the teachers now. But you can put in, you know, both a broader and one or more narrower at the same time, if you'd like. Or you can do it as you think of it. And if you feel you need to indicate it, hopefully I can guess. But that's one nice thing about the thesaurus model, is that using those short abbreviations of BT and NT. I mean, if you want to, you can still use those as well. You can say BT, what you think it should be, and what it should be for narrower. Okay. All right. Just goes. Okay, we'll just do the teacher ones now. I know someone had put something for help. Okay. First one was for teacher, broader mentor. That's interesting, because of course mentors can include those who are not teachers, but are all teachers mentors? Maybe some who aren't very good aren't. I don't know. I'm sort of stuck on that one. Okay, narrower, primary teacher. Okay, yeah, primary school teacher, I think was what's meant. That's fine. Narrower, teacher's aide. Again, I think it might be how you define teacher. They're an aide. They're not a teacher. They're an aide. So we'll let the experts deal with that. Okay. Broader, school staff, and narrower, math teacher. Yeah. I mean, a little tricky with the term staff for school, because they might say teachers aren't staff, they're faculty, and they make this distinction. It's an academic thing between faculty and staff. It's not just schools, you know, universities and colleges do that too, but I understand where you're going with that, so that's good. And math teacher, remember to put plural, math teachers is good. Okay, so history teachers. Okay, broader educators. Yeah, I like that one. That was the one I had in mind. That broader concept of teachers is educators. Narrower, kindergarten teachers, and more. Yeah, broader educators. Broader trainers. Maybe. I think I like educators better there. And yeah, because so the narrower ones we've gotten, yeah, the subjects, chemistry, math, history, and then the level to with a high school and or certified, or yeah, those are all good. Narrower, professor, I think that's fine too. All right, now let's look at hospitals, broader and narrower. If you want to put it, there are a few, we'll put in a few more. Okay, broader for hospitals, healthcare. Well, this is interesting, because is a hospital a type of healthcare? Actually, it's kind of, healthcare is so kind of vague. Is it part of healthcare? Maybe. So in this sense, it might not fit the syntax exactly. You know, I think more correctly would be healthcare facilities. But at your very top level, which this would be, like healthcare would be pretty top. I mean, well, it might depend. It might be okay. Just keep that in mind. It's not exactly okay. Then ICU as a, that's, you know, intensive care unit as narrower. Definitely that's the whole part one. That's good. Okay, let's see here. Broader medical center or medical centers. Yeah, I think there might not be completely understanding that, you know, or medical facility, because some are not hospitals, some are just outpatient clinics or something like that. And narrower, emergency room. or again, it should be plural, emergency rooms or emergency departments as a whole part. That's good. Okay. Government hospital, children's hospital, yes, is narrower. Broader health system. Yeah, that's like healthcare. It's again, it doesn't quite fit the, maybe it's a whole part. Oh, yeah. Narrower surgical hospital. Okay. Might be okay. I think most hospitals have some surgery, so I'm not sure about that one, but okay. Medical center. Okay, broader is health care facilities. That's good. Healthcare institutions. Narrower emergency room. Broader silent zone. I'm sorry, I don't know what that. Not so sure about that one. Okay, there's a question here, which I'll read here. How would you choose between broad or narrow of a concept or property? Like history could be a property of history teacher. All right, yeah, I get the idea, and it's really what's practical. At this point, you have to think about the users and how would they perceive it. I think most people think of history teachers. They don't think history is a property of a teacher. You know, teachers might be their certification, their education level, or it would be less. I mean, there could be some where I suppose it's possible, but it's really, again, how you design it. It's possible you could have the subject matter of teaching be a property, because you don't, but then people can't as easily search that way, you see. So yeah. And if you have different users, I think your question, what if different users have different perception of it? Yeah. That's why it's good to talk to some. That is one of the things you can do in interviews too. Like, is this something you would you search on history teacher, or would you just, or something like that, and you think of history as just a property? I'm not too sure how you would word it in the interview, but those are the questions that could come up. All right, so yeah, one with both of these, we were mixing different types of hierarchy, the whole part and the generic specific, especially with the hospitals. We had the parts of, we didn't have parts of teachers. It was the hospital ones where we had different parts of hospitals. And doing this, I want to say, that's why I'm addressing this, because I knew we were going to have a mixture of parts of hospitals like emergency and ICU versus types such as children's hospital, government hospital, or teaching hospital, or something like that. So mixing these hierarchical relationship types is acceptable in thesauri, which tend to be navigated alphabetically and not hierarchically. But in taxonomies or thesauri that do not display the hierarchy. But if you're displaying the hierarchy to the user, this could be problematic and confusing, because it's like you're mixing things. So it might then be better to not have them both and actually create different hierarchical trees or different facets. And I give an example, a possible way to go. You know, we can do what you want, but having, you know, your services, health services, hospital services, and then emergency is in a service of the hospital services versus a kind of more facilities approach, facilities, health facilities, hospitals, and then here have a specific name one, and you could have, I didn't even get into types, but this is a way to address it, to avoid confusion. Again, this is just kind of guidelines. I'm not saying it has to be one way or the other. That's what's fun about taxonomies. There's some freedom there. Okay, so we talked about hierarchical relationships, and then the associative relationship, related concept, which is suggestions of possible related concepts of interest. It's like a see also in an index at the back of a book. And by the way, I've done back of the book indexing, so I might refer to that a little bit more. So it's symmetrical and bidirectional relationship. It's related concept in both directions. And this is a standard required feature of thesauri. It's optional for taxonomies, but of course the two are sort of on a continuum. It's best for within a large kind of topics concept scheme, or if it's not a full thesaurus, but you've got a taxonomy, you've got topics and you've got places and you've got document types and activities or different things, and then you've got your topics, that it's within that it's probably, if you're going to have it, would be best. But it's between concepts within the same hierarchy or different hierarchies, but when I'm talking about, but usually within the same concept scheme. It's permitted across different concept schemes, but you might then decide, oh, you want to use a semantic relationship that's based on an ontology that's more customized when you're going across concept schemes. And yeah, if your concept schemes are used as facets, remember that example, the examples I had shown earlier, if you weren't here, such as a job board site where I had, a facet for kind of job function and industry and, level and location. You don't have related concepts related across those. They're just all going to be tagged to concepts, and if there's any relations, it will be seen in what's been sharing the same. And if you are using applying an ontology, and then so the fact that the concept schemes are corresponding to ontology classes, the concepts again should be mutually exclusive, and you would not be having this related concept relationship. So what's the purpose? It's to support, again, it supports the tagging and the browsing. So those who are doing manual tagging to find the potential additional suitable tags. And I think that's probably the more common usage. I mean, supporting in the user interface, it may require a little bit more work to set up, and I don't see it as often anymore. And it could be leveraged or weighted in auto tagging, providing context for natural language processing. But don't assume it like out of the box. You might need to do something to set some configuration to have associative relationships be considered. And then, of course, it can, as I say, can support user browsing if it's set up in the front-end application to make use of it. So let's look at the realm of possibilities for this related concept relationship. I took this list out of the standards, out of the ANSI NISO standards, but then I put my own examples to them. And you don't feel you need to know this list at all. I mean, I could never name what are the different process and agent, process and instrument. But the idea is this is kind of a broad scope of what's possible. And the order, again, it's reciprocal. It doesn't matter the order, but skiing is related to skiers, and ventilation is related to fans that are equipment. In parentheses, well, we only need that qualifier if we're including other kinds of fans. And okay, so you kind of get the idea here. Plastics, elasticity, petroleum and oil wells, and so forth. So they can be in the same hierarchy. They can even have the same broader concept, but generally what's the best practice here is to create the relationship if there's some overlapping meaning, okay? So the thesaurus best practices standards, ANSI NISO said, yes, that's when you should do it. So with taxes, there's a lot of overlap between local taxes and property taxes. Most local taxes are property taxes, and most property taxes are local taxes, but not all. But they're very, there's reason why you have separate concepts, because there's some different focus in the discussion. So they're separate concepts, but they should be related. Now, another example is if there isn't overlap. I mean, actually, don't ask me. Maybe tablet and laptop computers are converging, and there's something. We'll have to revise this. But right now, I mean, if somebody's interested in laptop computers, they don't have to be told, oh, there's also this concept of tablet computers. You might want to look at this too. You don't have to do that. That's just way too much, because, you know, different content is tagged to each, and if it's, you know, something about both, it can be tagged with both. And in fact, you know, in some tools, they might call this a valueless associative relationship. It doesn't have any value. Okay, so then the relationship between concepts in different hierarchies. So civil engineers is obviously related to civil engineering and the other way. And there's a hierarchy of engineers and occupations or roles or jobs. And then there's a hierarchy of functions and activities or disciplines, and wherever this comes from. So this is fine. However, now if these are in separate concept schemes in SKOS, they could be related with a semantic relationship instead, based on an ontology. So I just invented something here. Practices is practiced by. So the civil engineers practice civil engineering, and civil engineering is practiced by civil. I'm not sure if practice is the right verb here. I think it's more like doctors or lawyers. But you get the idea, is that if you want to, you can create semantic relations instead, and you don't need to, because they're in different schemes having, you know, that could correspond to different classes. Okay, so in practice, what I've observed is that related concept relations are within a concept scheme, and semantic ontology-based relationships are across different concept schemes. And then related concept relationships may be across concept schemes if an ontology is not applied. And so here's an example of we have two concept schemes, roles and skills, only two. So if there are only two, relationships are only between a pair of concept schemes, then you may as well just be simple and use related concept relationship, not create an ontology if you only have two classes. But if you had three even, and then you had different relations between the skills and the roles and this, you know, and something else. I mean, whether it was tools or locations or something, and it got more complex, then you'd bring in the semantic relations between the classes based on ontology, instead of just having related. Okay, so this one, I'm not going to switch over to the chat, but it's something you can think of now as our summary of relationships, especially the hierarchical and broader. So it's sort of like a quiz. Which kind of relationship is appropriate between these pairs of concepts? Oh, I should have set this up as a poll. Okay, search engines and search engine optimization. Is it has broader, has narrower, has related? So this, you just think about it, jot on a piece of paper, and I'll go on to what it is. And then search engine optimization and digital marketing. Is it has broader, has narrower, has related? Okay, let's see. Do I have my answers? No, I don't think I had a slide with answers. Okay, that should be related. I mean, I think if you might think it's narrower, but it's not. I mean, it's sort of a, you know, you add another word to it and makes it more specific. But search engine optimization is you know, making search engine, you know, concepts be pages and be found more quickly by search engines. So that's related. It's not hierarchical. Whereas search engine optimization and digital marketing, that would normally often be has broader. That's seen as a specialization within the field of digital marketing. Make your website found by, you know, by search engines, so it promotes your company and your brand. And it could depend on the context, but I think more commonly it's that way. Okay. So next topic, going into faceted taxonomy design. I'll pause here. Are there questions? And if you want to just speak up, or should I look in the chat? All right. Okay, we'll move on to this one. So facets, and I did introduce this earlier, but in case you missed it, and I do want to repeat it, and we'll go in a little more detail. So having sometimes people talk about faceted classification, meaning having multiple different classifications to an object. An object here would be a content item or something. And there are different classifications based on different types or different aspects or different dimensions. And they're intended to be searching with multiple terms in combination from each other. I talk about post coordination. That's where you're separating. That's where you could separate teacher and history. You know, you could have, and we were talking about attributes when that question came up, or characteristics. And there's this facets kind of cross over into attributes depending on how they're set up. But yeah, you could have facets for, you know, job title and role and certification and subject matter, but it depends. The focus is these are refinements or filters or limits to get at a set of content, and the set of content should share these facets. That's kind of the idea. So there are many use cases for it, but obviously not everything. So let's say this one on the right. This works if I have a collection of recipes. So everything is similar. It's the same type of content. They're recipes. And users want to filter the results by the type of dish it is, you know, or type of course in the meal. What are the ingredients, the leading ingredients in it? What are the cooking methods? What are the occasions? And then they can, you know, select that all the content should be tagged with at least one concept out of each facet. And here's some examples. It's especially common in e-commerce, so I'm sure you've all dealt with some things like this. Let's see, do I have now? Okay. So you had clothing, and the facets are very customized for this set of content. So for clothing, or this was maybe even tops or shirts, because we have sleeve length as a facet, or button down, or split neck, yeah. And then for books, you know, what is the format, the author, the series, and then software, format, platform, language, brand, operating system. And then the one on the right, far right, had to do with furniture, but it was already limited to tables. So there's a hierarchy of topics, and then specifically, so category is a facet. I don't know, we're kind of like, should that have been in the hierarchy? I don't know, but certainly material, the finish, and there we have our walnut, which doesn't need to have the word wood in parentheses next to it, because we're only talking about tables, not food and color and others, and facets of other kinds. So I'll assume, okay, none of you have anything to do with e-commerce, so we'll look at something different. So the first two screenshots are from Cornell University libraries. Of course, libraries have, this was specifically now for its thesis, format thesis. So theses can be in different formats. They can have, you know, you can filter by author, publication, year, language, subject. So we have subjects within facets, region. So subject region. So it doesn't mean it was published in that region, it's about that region. Or subject era, because let's say we have things that are in the humanities. So we're talking about historical eras, and so forth. Okay, the next pair of screenshots is from the Washington State Department of Transportation, and they have a lot of, for their projects. So State Department of Transportation projects, and then the facets, right, project status, active or completed, and the county, the region within the state, what the division is, facilities, rails, etc. And then there are different funding sources and different highways. would have to know that these are names of interstate or state highways and location and so forth. So you can limit, and then the boxes are, you know, tick boxes that you can select more than one from within the same facet. And then United Nations Education Program resources. This would be their categories, their topics. There's region and country are actually separated out from each other. So these are all examples of facets as a way to break out and organize a different taxonomy. So it supports more complex search queries by users. It allows users to control the refinement. They can narrow and broader. And what's nice is that it's familiar both to novice users and expert users. Now, some of the disadvantages is it's only suitable for somewhat structured, unified type of content that shares the same facets. As I said, all of a certain kind. And it's also, so that's where we're getting into, of course, content and data silos. Each facet, you know, set of facets will only work in a certain silo. But it's very effective in those silos for those who are using them. It's not practical for extremely large topical control vocabularies. How do you fit like all these subjects into a facet? You know, you can't browse. You'd have to search it. And it may or may not support some advanced search of multiple selections, but you could with those tick boxes. And it does require thorough indexing or tagging. So instead of just tagging a document for what it's about, you know, or, you know, especially based on natural language processing, what shows up in it, but you also want to tag for the document type and for the place and for, you know, and separate out people and whatever. So it has to be thorough. And that's because if something is not tagged, then it won't show up at all if someone selects from that facet, even though it exists. That's not good. Here's some more. Okay, this is interesting. Okay, you know, Etsy is an e-commerce site of you know, individual are people who set up their own shops, and they sell all kinds of craft and all kinds of things. You know, lots and lots of things. So here we're actually getting into really attributes. The facets. I'm talking about facets, but we're really getting into attributes. So someone, you know, on the left here, necklaces, narrower. Okay, under jewelry, then they narrow down to necklaces. So the user's already gone through a hierarchical taxonomy, and now they're at the lowest, you know, the point, or they can even get lower to pendants or beaded necklaces. And then all these 4 snippets of screenshots I took are listing the attributes that they function as facets to limit by as well. I mean, here we kind of cross over what's the difference between a facet or an attribute. But some of them, I've kind of color coded them, but some of them are specific to the ones with red, are specific to necklaces. Gemstone, chain style, closure. Well, yeah, those are obviously specific, where the ones that I have in purple are a little broader. They're not used just for necklaces. I mean, they are used for gifts when it says recipient or occasion, but a lot of stuff can be gift or theme. They're interesting. And yeah, again, of course, what goes in a hierarchical taxonomy and what goes into its attributes. So, and I write a blog, and my latest blog post was on attributes and how I talked about this. Anyway, I didn't show that screenshot. But I mean, I'm kind of going a little beyond, you know, if it's something like products or e-commerce, you already have a hierarchical taxonomy, and then you filter by facets that are really attribute types versus those other ones I showed you of like the Cornell libraries or the Department of Transportation, where your facets are more your starting point, and they're broader. They're not just attributes. So some tips for designing that kind of facet, not the e-commerce extreme one with Etsy. The number of facets would be like in the range of 3 to 8, maybe 5 to 6 is ideal. And they should be in logical, not an alphabetical order. And the number of terms per facet would be like, you know, 2 to 25. So you know, the user can browse them. If we have a longer list that's alphabetical, you know, all 50 U.S. states, that's okay. And maybe an exception for topical ones. And then the idea is whether they should be this order, or should they be in alphabetical or logical order. I found like around a dozen makes kind of the tipping point. You could have a 2-level hierarchy within a facet as an indented display, but just keep in mind that it's not always a lot of space to display. And then in SKOS-based software, each facet is managed as a concept scheme. All right, so what we're going to do now is we're going to take a break and do a breakout session. So we're going to kind of combine that. I need to set it up anyway. Yeah. So we'll I guess that means I'm going to set up 9 breakout rooms. One for I'm just going to. So I mean, we'll start with the break where I'll actually set this up. I didn't do it ahead of time, and then so we'll have a 5-minute break, and we come back from the break. Then you do the exercise. So join a breakout room of your choice when I set it up, and they will be on these different topics. If you find there's only one person, you know, I mean, you can kind of go where you want. You know, it's nice to have 3, 4, 5, 6 people. You know, not 8. It's too many, and not 1 or 2, that's too few. So you might have to move around. And then enter in your taxonomy into a Google Sheet, and I will put this into the chat. And I have a different worksheet tab for each of these. I think I have all 9. I'm not sure. Or maybe I ended with 7. I'm not sure. I'll set it up. Okay. So like I said, I'll have this, you know, if you want to come back from your break a little earlier, but we'll have a break for 5 minutes and then go right into this. All right. So where I have this.
Can I help at all, Heather?
Yeah. Actually, let's see. If I put this into the chat, which I will do, and I will also, put this link into the chat. But wait, I didn't put it in yet, did I? Or did I? Yeah. No, oh yeah, I didn't hit enter. That was it.
Ah. So would you like me to create the 9 breakout rooms?
Yes, if you could do that.
And the titles for each that list there. So digital assets, images, and other video files being the first.
Yeah, it would be good if they had the name.
Yeah, no worries.
Yeah, I'm sorry, I didn't ask for that before, but that's fine. Okay, because we have a break anyway. And okay. I believe I'm sharing here anyway. If anybody's still hanging out, that's okay. So the first worksheet is just the example, and then I do have numbered and named tabs for each of the other ones. And is that working?
You seem to be limited to 3 breakout rooms.
Only 3. Oh.
Which we don't seem to be able to control the name of.
And we can't control the name of. Okay, let me think here.
I'm just going to confirm that while you're having a think.
All right. Well, I guess we'll just use 3. They'll be a little large. Okay. But but people can talk to each other in the breakout rooms, right?
Yes.
Yeah, that's the important thing.
I mean, basically, the easiest way of doing it, I believe, is that we just randomly put people through the 3 rooms, start the rooms, and then they will go into them automatically.
All right, if that's easier, we'll do it that way. Okay, then I'll. Okay. Yeah, we'll just do the first 3 if we can only do 3.
I know. So I beg your pardon. 5. Sorry, it's the way it was.
Oh, 5 would be nice. Yeah, just do the
so
first
we have
5.
5 rooms. So I could easily, well, I think if I randomly scatter people, so there's actually 4 in each. 4 in each. If I then start, basically, as soon as I start the rooms, people will be moved into them in their browser. So shall I just wait until people are coming back, or you want to start this process and maybe explain?
No, I think if you can do it. Let's see. Okay, I'm going to put that. Oops. Well, I think they might be coming back now. Okay. Okay. All right, put it in twice. All right. I think it's been about 5 minutes.
Okay.
Okay, so I had originally said you can choose your own breakout room, but we found that it's more efficient to get randomly assigned. and the system supports 5, not 9. So you will be assigned to either digital assets, technical documents, health information, events, or training content. So this is all, again, focused on the content, and I said facets should be for content of a similar type. So these are the types. And so in your breakout room, and you're welcome to please participate and talk and introduce yourself to those who are in your breakout room, and then together you can collaborate and fill out, first, the first column is a facet name. Now I have here example. I'll leave this one as I'm sharing. Here's an e-commerce one, for women's shoes, the type, the brand, the color, the material, and the size, and some sample terms in the facet. So you would do that for each of your other ones. You may, on occasion, decide you want a 2-level hierarchy, and you could bring something out into the column C. But I mean, I think in most cases that's not necessary. But if you decide to do that, that's fine as well, depending on what it is. You might need to initially talk about a little bit about the use case, agree who are the users, and what is the content. Make sure your team is agreed on that. And then put in something. And I think, it's not too. I don't think we need more than 10 minutes on this. I mean, we'll come back to discuss it. So at 13, so at 23 past. If you finish early, I guess you can have discussion among yourselves or something. It's always nice to network a little bit, right? So I guess I might be able to. I mean, I can view anybody else's sheet as well. And let's see. So I did put that link in the chat. Everybody should go to that link. That was here. Okay. We don't need to look at anything on the slides. All right. So are people in breakout rooms?
Going there now.
Okay. You do need to I guess, snag that URL out of the chat before going to breakout room. Hopefully someone did it and can share it with others. All right, I see that the people are in the rooms. And I can visit the rooms?
Yes, I believe you can click on those links and go in there. So
yeah, what I might do is just
grab the link and yes.
Yeah.
Cool. I've popped that link into the rooms you hadn't got to yet.
Oh, no.
You need to stop sharing your entire screen for a second because you're feeding back.
Oh, okay. All right. If I want to stop the breakout rooms, I just click close, or you can.
I'll do that for you now. I'll do that.
Yeah, yeah, do that now.
There we go. Wheels.
Okay, so I had shared this one, and I'm sorry the breakout rooms didn't seem to work very well. I mean, of course, I've done this before on Zoom, which we're all more familiar with, and that worked. But so some started with digital assets, topic, status, and format. Yeah, this is fine. Actually, I think this goes beyond just digital assets, but any kinds of documents. It's rather generic. If you want to add more to it, you can. And then I think the only other one that I saw people worked on was person profiles. Okay. Yeah, this is really taking more of an attribute approach. And it said, you know, I mean, what's the difference between a facet and an attribute? Well, it depends how they're being used. I mean, if you start as a starting point, and these are certainly the example I had was more of a starting point. Then they aren't. We call them facets. And I think I go back to my slides and show which are more facet-like and which are more attribute-like. So this is definitely attribute data, because it's not something that I want to find all the people who live in zip code 98101. You know, it's not an entry point for queries. That's how you kind of define it. You know, this is still good information, but I mean, I'm sorry if I kind of confused it, but that in a sense it's important to know what data, and this is really more of a comes to ontology modeling than taxonomies, because we said that, you know, what this is here is definitely not taxonomy. This is data modeling, and you might want to consider it in your ontology for the attributes in an ontology, but not a taxonomy, and not what we would call a faceted taxonomy, because again, it depends on what needs to be a starting point. As I said, like who has phone number 206-890-1234. It doesn't make sense. You know, it's not a query point. It's like it's a data you get afterwards. So I think that was all I completed. So yeah, that was interesting. You found that was a little bit a learning still of interest. So I will continue with the presentation now. Okay, yeah. So now this is a good point. Faceted taxonomy versus ontology. So the facets are about shared aspects of a specific set of content, different ways to categorize, classify the content. And so, for example, here, when I showed the recipes, the content of recipes classified different ways on a recipe website. Classes, so I'm not talking about facets versus attributes. I'm talking facets versus classes, because they're both set up as concept schemes and the taxonomy thesaurus management tool that is based on SKOS. Classes are about shared sets of related things in a subject domain or business objects across an organization. And so if we were still using the same, essentially, taxonomy on, now we talk about the domain of cooking. We're not just talking about recipes. So what is involved, let's say from a company that sells cookware, they might, and maybe they're selling some ingredients too. So there would be recipe content, but then there are also, let's say, articles that are about food, and then there's some, it does cooking demonstration events and courses, and so there's more going on, and so then you would set it up as classes, and then you would have those relationships go across, and not just the taxonomy. And we'll get into that again, but I have a couple of slides just here while we're still on taxonomies and not moving too much back to ontologies, is on governance. So while ontologies don't change so much, taxonomies do, and I did mention that earlier in their first section. So taxonomy governance can cover a lot, but most fundamentally is the policies and procedures for maintaining the taxonomy through updates and changes.
Heather?
Yeah.
You're not sharing your slides, I think.
Oh, okay. I'm sorry. Nobody said anything. All right, go back. No. Okay. Oh, wait a minute. I have to...
You're sharing a Google Sheet at the
moment. Pause sharing, and I'll have to start sharing it. Stop sharing, and I'll share again, I guess. Is that now?
Yes.
Yeah, okay. This is what I had just said, right? It was just a bunch of words. Okay, governance. Okay. Yeah, ontologies don't change so much. Taxonomies do, because, and what you need governance to, especially to manage maintaining taxonomy through changes, that terminology changes. There's new content. Some content may get drops. There are new requirements, new users, new trends, new markets. User feedback suggests changes. And actually, taxonomy governance, when you build a taxonomy, isn't something that comes at the end. It actually starts from the beginning, because as you create the taxonomy, questions will come up. Should we do it this way? Should we do it that way? And I hope you saw so far through all this that I've explained, oh, sometimes it depends. You might do it this way, you might do it that way. And so then you need to document it, the decision that's made, and that document builds up and becomes your policy. So governance comprises you should have some descriptive documentation about the taxonomy, its purpose, its type, its scope, its users, right? How it's going to be used for index, and then the kind of history background, where it came from, what are the sources, what should be sources going on. And then if there is different aspects to it, different concept schemes, different rules, you have document types. Are you allowed to have more than one document type on a document? Usually not, maybe, or something like that. And then those guidelines for maintenance and updating. And then also guidelines for tagging. Okay, what's the policy and guidelines for that? I mean, it's a little bit easier to do that for manual than for automated, but there's still ways you can set some parameters for automated tagging as well. And then any kind of instructional and how-to documents. And then what I was saying, guidelines for maintenance, I was really focused on, this style and so forth, and what are the criteria for adding new concepts, how much content is needed. But then there's also all that around of responsibility, roles, processes, and procedures. It's kind of more business side of knowledge management. But for the editorial policy, the questions about capitalization and abbreviation and style and special characters, how complex and, the concepts should be, bring them together or have them separate. What types of concepts to include, what are some authoritative sources to consult to look for the concepts and labels, any guidelines for alternative labels, how much do you have, are you having associative relationships or not, how deep the hierarchy should be, is it going to be strictly only 2 or 3 levels of hierarchy, whether collections would be used, and any policy around scope notes or definitions or other notes, because that's purely up to you. I mean, some organizations say everything has to have a definition, okay, because they're kind of doubling it for a glossary. But other times, only definitions when it's it's something highly technical, or we're not using definitions. We're just using scope notes, and everything has a scope note, or only as needed. And then the tagging policy, various rules, and it could be focused differently for different concepts, schemes. I said, different for the subjects, different for each individual name authority will have certain policies. If it's a list of names of people or departments or organizations. And there could be rules. Can you tag, as I said, for like document types, must it have only one, not more? Must it have one? Is it required or not? And subjects or topics, how many? Not 10 is way too many because it kind of dilutes their value. Is one too little? Should it have more? These types of guidelines. There's also a question of should you also tag with the broader concept of something, and that can be a policy you decide to have or not. Okay, so that was a very brief section. Now we get to the final topic, which is of course the most interesting, which is semantically enriching a taxonomy to become an ontology, or from the others, extending a taxonomy to be an ontology, or applying an ontology to a taxonomy. So there, as I alluded in the first part, there are different options for creating an ontology that if we define an ontology, typo there. Okay, an ontology that comprises both the semantic model and the individual instances. There are two approaches. One is you use a dedicated ontology tool, or even hand code OWL, which maybe some computer scientists like to do, to build out the full hierarchy of classes and subclasses and subclasses and instances within the ontology. And this is, like using the most common ontology management tool, Protege. You can do that. And this way you follow ontology standards, but you're not following thesaurus standards, especially with the hierarchical relationship. You can't have the whole part and other things like that. Or you could take a taxonomy ontology tool that combines creating a taxonomy and ontology and then link them together, with the ontology functioning then as a semantic layer, so to speak. And this way you're following both the thesaurus taxonomy standards and ontology standards. But I'll still go into a little bit on using a dedicated tool of how you have all the classes and subclasses and instances. And then the ontology is as detailed as any taxonomy or thesaurus. You have multiple layers, and but you do support all OWL features, including constraints, reasoning, inference, which might not be supported in another tool. So this is good, but the thing is you can't, as I said, extend an existing taxonomy. And many organizations already have existing taxonomies around. I mean, taxonomies are not new. They've been around now for maybe, a couple decades, or many organizations, at least a decade maybe. So you want to make use of them. So that's why starting with a taxonomy and building up is good. But I will show a few screenshots from Protege. And this is of the web Protege. There's also, you can download a version. So these are examples from FIBO. This is a financial industry business ontology. And what I'm showing here are classes. So they're classes, properties, individuals, and so forth. And you can see 1, 2, 3, 4, 5, 6 levels of hierarchy of subclasses. It's very detailed and extensive. So it's like a taxonomy, right? But it's just, meant to be a generic model. That means any financial institution can adopt this. It's not specific to a specific financial institution. So these are the classes, and a selected class mutual contract agreement. You can see over on the right the details of it, annotations, parents, relationships. So annotations, what's interesting here is you see I referred to RDFS before, so it has, and SKOS, you see SKOS definitions. So you can actually pull in from different W3C models or standards into here. So because OWL doesn't have a definition field, but SKOS does. Parents here just mean the class it is a subclass of. So you saw this comes under both contract and mutual agreement. It's like a polyhierarchy. Okay, so that's classes, and then now we're over to properties, right? And according to Al, there are two kinds of properties, object properties and data properties. This is object properties means relationships. And it's, I remember originally thinking, this is confusing. Why are they calling relationships properties? But then I came to realize, you know, there is some similarity to them and the attributes, because sometimes you have to decide, is this a relationship or is it an attribute? It could be either. So there's this decision in designing it. So grouping them under properties does kind of make sense. Okay, so relations, again, we're still in the 501 here. So I've selected this relationship called authorizes, and it's interesting, even the relations can be in a hierarchy in OWL and protege. So authorizes is a narrower relationship to acts on. And then he even has narrower relationships to it, delegates control of and designates signatory. Oh yeah, when you think about it, yeah. I mean, they're all predicates, right? These are the verbs, so they can have specific types. And then over on the right, again, the details of the relationship type called authorizes. And then here, domain and range, and that's important, because all relationships have to, they're the predicates. They have to fit between the domain, which is the subject, and the range, which is the object, which are classes. And so the domain is authorizing party. The authorizing party authorizes, and the range is the authorized party. Yeah, that makes sense. And then still properties, data type properties. So these are the attributes. Yeah, here we see all that thing about address and phone number and that type of thing, which is additional data that's useful because we have it, right? But it's not an entry point to a search or a query so much. And again, the annotations, and then domain here is, okay, it has only a domain, it doesn't have a range. That's what's specific about attributes or data type properties. I mean, you can say in a sense, so it doesn't have a range, but you have to have a triple. So the object of the triple is the value, what is in there. So the data type property here I selected allows payment in kind. I mean, that does sound kind of like it could be a relation. But you know, if you go over and see what range, Boolean, what does that mean? Boolean is like, yeah, it means one of a choice, yes or no. So some of these isn't even a value. It's just like tick box, yes or not. So that's, I'm just showing that as a different kind. So what it means is the domain redemption provision may allow payment in kind, or it may not allow payment in kind. And then you have the value yes or no, it doesn't. So maybe that was all a bit confusing. And then fine, so those were the classes and properties. Now I'm going over here at individuals. The individuals are tied to a class, and the class here is jurisdiction, yeah. And then here we have the individual, in this case, Federal Reserve Bank branches or something, or names of individual jurisdictions that go with it. And they have some other information. So that's how an ontology and a dedicated ontology tool like Protege will include everything. It does include all these instances too, and there are other instances to all those other classes as well. But again, this is not the, if you're starting from scratch and developing top down and you have no taxonomies that you want to start with, you could consider this. There's a steep learning curve to it, and this is what ontologists do, and taxonomists will, this is too hard. But as I said, I do not recommend importing a taxonomy into an OWL-based ontology or dedicated ontology tool because, and there's both a relationships and alternatives issue, as I alluded to. The taxonomy hierarchies get converted to class-subclass hierarchies. The class-subclass hierarchy in ontologies is only the hierarchical type of generic specific, is a kind of. So the other ones, the whole part, will suddenly become class-subclass, but it's not that a whole part is a subclass, like, I give those examples like stomach and digestive system. It's not like it's a subclass. You know, it's not a stomach is not a subclass of digestive system. Massachusetts is not a subclass of New England. So those are not subclass. And then of course the generic instance is also completely different. I mean, while that would be in a hierarchy, in a taxonomy, they would then get converted to class subclass when they should be class instance affiliations. Actually, often instance in a taxonomy won't be narrower to the generic. Often they'll be in a separate concept scheme anyway. And then there's the issue of the alternative labels. Yeah, they can get imported. They get imported into annotation as well as a property, but then they don't really function as alternative labels in supporting tagging and in supporting search, and that's very important. And then you get into, well, hidden labels, I don't know, no distinction, or different languages. So all that linguistic side of taxonomies and controlled vocabularies is not something that ontologies are strong on, you know. So that's, you keep that in the taxonomy and you link it. So yeah, so approach number 2, yeah, combined taxonomy ontology tool. And yeah, I work for the vendor of one of them, Pool Party, but our competitors do that too. This is not something extremely new. You know, it goes back maybe at least 10 years, to create a taxonomy and ontology, and they'll link them, and the ontology functions as a semantic layer. The ontology comprises the classes and subclasses only to the extent needed to describe the generic characteristics of the semantic model, and then more details of hierarchy can be in the taxonomy. So it doesn't have all levels of hierarchy. You don't have a 7-level hierarchy of subclasses or something like that necessarily, nor the instances. And more of the hierarchy and the instances reside in the SKOS taxonomy. Okay, so back to our recipes example. So I said, the first screenshot here on the left shows that recipes taxonomy, but let's say I want to extend it to the ontology because we want to go beyond just recipes and deal with the whole realm of cooking, and we're going to add another concept scheme on, you know, cookware, because there's something like that. So then we want to have classes in ontology that map to, in this case, I have it very simple. They map to the concept scheme, which is the top level, and the purple cooking method, dish, ingredient, occasion. There's no reason it has to map exactly that way. You can map a ontology class to a top concept or any concept, and then its properties are inherited by everything that's narrower. So that's pretty nice. So the taxonomy plus the ontology layer. The ontology then will tend to be smaller and simpler. That's what you see on the right. So now you see my recipes ontology has 4 classes, no subclasses, and then a few relations. And if you can't really see it in this visualization, but there are other displays will show what's a reciprocal. So goes with goes in both directions, but, you know, has ingredient, and the inverse is included in, you know, prepared by method, or has the inverse for cooking, served on occasion, and has the inverse features, the occasion features a dish, and a few attributes here. So the taxonomy then would be based on SKOS, and the ontology is based on OWL. But they are compatible because they're both based on RDF. So that's what's really it wasn't until we have those standards from the World Wide Web Consortium that we're able to bring together taxonomy and ontologies. Before that, you know, taxonomies were based on thesaurus standard, and they were created by taxonomists and thesaurus people and librarians and catalogers, and ontologies were developed, you know, more in the field of computer science. And different people were working on them, and they weren't even talking together. But with the W3C standard, semantic web, they've come together, and taxonomists are getting interested in ontologies, and ontologists are getting interested in taxonomies. That's great. Okay. So yeah, just continuing this, extending SKOS taxonomy concepts to be part of an ontology. The ontology class labels correspond or match to the SKOS concept schemes or concept labels to which they will be applied, as I said. So I'm talking about the ontology layer, but it's actually not an upper level. It's really an overlay. So these are kind of matching, cooking method goes. I think it's good practice to put your classes in singular while in the concept schemes are in plural. Actually, it doesn't. Your concept schemes don't have to be in plural. When I talk about plural as a good style, that really is for the concepts, everything in green that's used for tagging. The concept schemes that are in purple here are groupings that are not actually used for tagging. So you can put them in singular too. That's just fine. But when I'm mapping an ontology to taxonomy to kind of keep things straight in my mind, I'll leave the concept schemes in the taxonomy management area in plural, and have the concept have the classes in the ontology over on the right in the singular. That's why I said that tip there. And also that you don't have any dilemma of determining if an entity is an individual, instance, or a class, since the ontology layer combines only the classes. What dilemma? Okay. I remember kind of when I first thought of individuals in ontology, oh yeah, that's like name authority, proper nouns. But no, they mean literally individual. There can be only one. That's why I gave the example of a Samsung Galaxy, where that would be, oh, that's a name authority. It's the name of a product, and it has certain attributes. Whereas in ontology, strictly, no, it's like, it's Heather's phone. Then it's one. It's unique. It's an individual. And trying to separate that, especially when it comes to products or things like that, gets a little confusing in ontology. But you don't have to worry about that if you just have all the stuff in the taxonomy, and the ontology is really just the model. Okay, so a little more step by step, and I do have a couple of screenshots here from Pool Party, how it's done. I'm not exactly sure how our competitors do it, but something similar. Okay, so an ontology or custom scheme is applied or linked to the taxonomy project. So you have to do it first on the project level, and then to so I go under advanced, select custom scheme. So actually the ontology is then pulled into something called a custom scheme, so you can make a mashup of different ontologies, and the custom scheme is applied to the whole project of recipes. And then the next step is that classes are applied to the level of the concept schemes or top concepts or broad level, wherever appropriate, although usually the concept scheme. So therefore, in the next screenshot there, I've done a right click under the concept scheme of dishes, and then in context menu, apply custom class, and I assign the class of dish. Remember, I had it in singular. And then the relevant relations and attributes will become available for all concepts in the taxonomy that are narrow to that based on their class assigned and their broader concepts. Okay, that makes them available, but what about, I want to create those individual relations and those individual, put in the attributes. So that's what I mean by instantiating a relation or adding values for attributes. This could be done manually, or it could be done in batch mode through importing spreadsheet tables. It may depend on the tool, but I mean, in Pool Party, we can do this. This would be an example of how it's done with a spreadsheet. So if I've already set up the ontology and I've created relations, then the key is the first concept column, and I have names of companies, and this one is a job one, so that's why I'm calling them employers. So those will be in the taxonomy. And second column B, type. That is everything now is based on the URIs. Okay, so this is the URI for the class that I've created in the ontology. In the ontology, it's called employer, and the rest of the URI is the project and the server and the whole thing. Next column C and D are for relations, and I put the URI of the relation. If you can read this, belongs to and has HQ, headquarters, in. So I'm relating a company to the industry with the belongs to relation, and then I've actually listed the industry. So here I'm putting the actual one it should connect to, and then the relation is the country, and I have a concept scheme for country, and then columns E and F are URIs not for the other properties, not relations but attributes, but it still kind of works the same way. So I have the URI for the naming the attribute that's called address and an attribute that's called phone number, and then I have the specific numbers in it, and I import that, and I get the results. Sorry, I switched like domains. Maybe I should have done a spreadsheet for cooking, but but I had that one handy. All right, so back to, okay, this is a taxonomy in SKOS, and yeah, you see SKOS broader, narrower, related. So fruitcakes has broader cakes. We're getting into Christmas season, so I decided to put fruitcakes. Some alternate labels, like Christmas cake, okay, of dried fruit. And then to the right of SKOS, you see something called recipe scheme. So that's my custom scheme based on ontology. And what here, I can then, instead of broader, narrow, related, I have my semantic relations. For occasion, goes with, has main ingredient, prepared by. And so those are relations to concepts in the other classes, which are the other concept schemes, and some other attributes, number of calories, preparation time, served. In this case, I think it's pretty clear what's a relation and what's an attribute. But yeah, there are times that you have to think about it a bit. Okay, checking the time here. Oh, we're almost out of time. I think I'm almost at the end. So summary, applying ontologies to taxonomies. Benefits of combining a high-level ontology as a semantic layer to a taxonomy. Well, it makes use of existing taxonomies, or multiple taxonomies even, and more they're existing around. I think it's easier to model the ontology because it's not quite as detailed, but also because you have existing taxonomies can provide a basis for the knowledge modeling. I mean, knowledge, I'm not getting, we could have a whole nother tutorial of 4 hours just on ontology knowledge modeling, and there are people who've done that, and they've done a great job. But there are issues, looking at those spreadsheets of data, but it also is good to look at what you have as taxonomies. And you don't have to worry about what's the difference between individuals and subclass. And I think it supports the expert specialization better. I kind of alluded to this because we have taxonomists who work on the taxonomies and ontologists who work on ontologies, but they'll collaborate a little bit too and get to know each other. But it's not kind of stretching people too far out of their comfort zone. I think it's more flexible and adaptable because, as I said, the taxonomy changes more frequently than the ontology does. And you can add more taxonomies. And, there are different purposes because the ontology does have serve additional purposes, the modeling, the reasoning, inferencing, analysis, and the taxonomy is then for tagging and information retrieval. So as you build it, you can focus on what your use cases are, and then they bring them together. So summary, yeah. Extending a taxonomy beyond ontology provides more uses than a taxonomy alone or an ontology alone. Make use of existing taxonomies, and then conforming with standards. You can conform both to the thesaurus standards and to ontology standards, but you should start with a taxonomy in SKOS. Okay, I mean, there are taxonomies out there that aren't in SKOS, but that's where we're going. And as I said, it's best to use a combined taxonomy ontology tool that's based on the W3C semantic web standards, such as pool party. And just an example here. Okay, if I go back here. So we have a extensive taxonomy on cocktails. It's a sample one. That there's a taxonomy. Well, actually, maybe I shouldn't go through. I could have these one by one of showing the different components and things that go together, and ingredients and glassware for. So that's your taxonomy. This is the ontology that goes with it. It does have some hierarchy here of subclasses and relations. Uses drinkware, uses garnish, as part of, is used by, and some other attributes. Images can be attributes too. You bring those in. That's cool. How it's prepared, served. IBA is the International Bar Association. It has something to do with it. So those are the taxonomy and ontology, and then bring them together, and you can get details. So here's an example of a drink. I know nothing about a cocktail, Harvey Wallbanger, But again, what you see, yeah, of the cocktail scheme, it consists of different ingredients. It uses a drinkware. It has garnish, and then the attributes, the links to the images. That's nice. Okay. I just want to show it though in a front end tool. I'm not going to give a demo, but you can go to this. Facets over here on the left. You know, we can look at, you know, ingredients, cocktails, but what's down here is interesting. Consists of, is part of, is used by, is variant. So the semantic ontology relations are being used in a faceted form of limits. So that's an, I don't know, I haven't seen it anywhere else, but so you can actually put an ontology into a kind of a faceted way of doing things. So here I then would limit by, you know, I chose an ingredient and that it's a part of, and I limit it that way. I think, yeah, ingredients, and then or from another direction, choosing the cocktail type, and you know what, so you can choose different attributes and start one way versus the other way. Okay, so this is finally put everything together. Taxonomies and ontologies are actually only at the very crawl stage of your knowledge graph, which is at the fly stage of crawl, walk, run, fly. I think I should just stop now because we're out of time, but I'll make available the slides, and I have the links here for guidelines and lots of links on taxonomies and my contact information. And I mentioned my book on taxonomies. I presented at another conference 2 weeks ago, KM World, and so they offered a discount, and that discount code is still available through December 15th of 25% off if you enter in KMW21 at the publisher website. So, you know, I wasn't even sure if I think we're going, yeah, I thought we were ending, I don't know if we're ending right at the hour, and then the next session starts at 1/4 or what now. But I'm certainly around for questions.
I believe it runs to 1/4 the hour, so plenty of time for questions.
Okay, I was kind of rushing there at the end. All right. I'll look at what's in the chat, although I'll go through the chat, and then you can also ask verbally as well.
People just remember to unmute themselves, and they can.
Yeah, but you are alone. Okay. Okay. So question, how do we represent a relation between dish and dishes? That is, the property what property do we use and should exist in the ontology or taxonomy, or both? I'm trying to figure out the question. I mean, with the relation between dish as a class and dishes as a concept scheme in the taxonomy, is that the question? Because it exists in both. And let's see, I did stop sharing. Oh, wait a minute. Again, if I guess it was sort of this slide, right? Am I sharing now or no? I forget. Am I sharing?
Yes.
Yeah. Okay. I think the question was, what is the relationship here? I just drew arrows, right? And that's not really clear. The tool will establish a relation, and that was done here. I said in dish, apply custom class dishes, and so it's when you have a combined taxonomy ontology management tool that you can link them up together. So it exists, and it has a different label. I said between plural and singular. So exists as a concept scheme in a taxonomy and as a class in ontology. But you can map it at any level. It doesn't have to map something that has exactly the same name. So I hope that helps. Okay, let's see. How do we yeah, okay. Can you show an example of a taxonomy ontology in a knowledge graph? No, I don't know if I can show it. It's hard to, you can show an application of a knowledge graph, because remember here I'm just showing concepts and maybe instances, but I'm not showing further data. Okay, maybe data as far as attributes, but I mean other content that's linked to, and the full everything that you can go through, you would actually need to, I mean, that's where we draw the line between the knowledge organization system and the knowledge graph that includes the links and of all data and others. So yeah, I mean, I guess when I was showing that little thing with the cocktails, we could see a little bit of data. Sorry. Okay, what vocabulary or specific property one could use to link a class with a concept in a concept scheme? Do we define our own properties to establish the relationship, or are there existing properties that we can borrow or establish a relationship? Okay, as far as, you know, there are existing ontologies out there, and I shared FIBO as one, and this other org one. There are a lot that are available, and they're also available through Bartok and other sources that you could then import into Protege or import into other tools like Pool Party. You might need to do a little bit of manipulation to get it right. So you don't have to reinvent everything. You don't have to define all the properties, the relations, and the classes. And then typically what you do is then take some of an existing ontology and maybe extend it with your own custom ontology. It depends on the use case, really. I mean, there's one gist that was developed by the consulting company Semantic Arts that's meant to be very general, and it's also a good place to just start thinking, even whether you use it or not, from the high level. Of course, both taxonomies and ontologies, you come to it from, you talk about the bottom up and the top down approach. Okay, for taxonomies, yeah, that, you know, the top down is, you know, you talk to the high level stakeholders. What do we need? You do a brainstorming session, you know, that's, and the bottom level is, you know, you do the extraction of terms automatically from a corpus of documents. You look at the search term logs, and, you know, you get term lists from people. So you're coming from both approaches. Ontology is actually both too. I mean, the top level would be, you know, look at what other ontologies are in the domain. Again, talk with people to find out what are the problems you're trying to solve. What are the questions that people are asking, and this could then model where you need to divide things into classes. And then the bottom up is look at those spreadsheets of data and look at the columns, and then figure out which of those columns, oh, that grouping, that could be another class that we relate to with a certain relationship, or that this one should be an attribute, or that type of thing. I hope I kind of answered that question. Yeah, feel free. You know, I don't think there are more questions in the chat. So if you want to turn off your microphone and just talk, that's fine.
Hello, Hedden.
Yeah.
Good afternoon.
Thanks. Yes, it's now afternoon for me. Just
Right. So thank you so much for the talk. I really appreciate that. It was quite insightful. So I'm just coming back to the question that I asked through the chat.
Okay.
So let's say you have the ontology, or you have a class defined in an ontology called dish, and then you have a taxonomy. In the taxonomy, you also have a concept scheme dish, or let's call it dishes, right?
Yeah.
Now, if you want to link the two together, should we be using some existing vocabularies, for example, SKOS related, all same as one of those?
No, when you link them, that's something different.
How would you define that linkage? Do we have to
I
come
don't
up
know.
with
I
our
mean,
own?
because it's done in the tool I have, I don't think it's defined as a certain link. The links are all within an ontology, or they're within a SKOS taxonomy. So yeah, I guess I could see if I could check with someone more. I mean, a colleague of mine who knows that about the tool I use. But I mean, the tool that I use, Pool Party, does not show that as a link. I mean, at least in the user interface, it's kind of like, yeah. I mean,
right, but you get the idea, right? So, because if you want to link the class to a concept scheme, you need to have a property, which we call the predicate, to establish the linkage between the two. What would that be? Could we use some existing vocabulary for that purpose, or do we have to define that relation or that object property ourselves that actually link the two concepts?
Well, again, if you're using a combined taxonomy ontology tool, you don't have to define it. The tool does it, and I guess there.
But outside of the tool,
you're right. You're right. There should be an RDF triple somewhere that's specifying that. Yes.
Yeah.
I mean, I haven't gone and looked to see what it is.
But outside Pool Party, let's not talk about Pool Party. So
right. I understand.
What can you use?
You would be asking outside. Yeah. Okay. I mean, I'll look that up. I don't know if I. Okay. I mean, I could go am I sharing my whole screen? I'm sharing my whole screen, everything. I mean.
No, you just see the slide deck.
Yeah, because if I went to Pool Party, I mean, am I sharing Pool Party? Because I can look at triples in it. Let's see.
We can just see your slide at the moment.
Yeah, okay. I will then change that. Wait, share. No, I don't know. I'll have to stop sharing and reshare. I'm not sure how I change this. Okay, now you see the recipes taxonomy. All right, and I think, all right, this shows that it has cooking method on it. I mean, if I go to triples, I mean, that has everything. I mean, how I find the one that indicates the relationship of a concept scheme to a concept, I'm not sure. That's what I said. I don't usually go looking at the triples. But I will say, see here, dishes, it is, this is just a user interface thing telling me that it's associated with dish in the concept scheme.
So if you click on triples, can you search for a thing called dish? It might tell.
Right here, actually, because that would be a sub.
Yeah, maybe if you just search for dish, it may tell you which program it's using to link.
I don't know where that came from. Right, DC. So type.
Oh, it's the applied type, I believe that's
the one which is actually linking. Applied type.
Right. Oh, okay.
Yeah, that must be it. Okay, because that was dishes. Okay. All right.
Just kind of like a bespoke or your own, like when you can define the relation yourself, you don't necessarily have to use one of those standard properties like SKOS related or all same as or C also, those are things to establish those links between ontology and the taxonomy. Right. Got it.
Right. Okay.
Thank you.
Yeah, sorry I'm a little slow in answering your question because basically I am more of a taxonomist than an ontologist.
Yeah, no worries, I get that.
But
Thank you.
we were looking in things here and you can see. Oh yeah, I was just this is live and our desserts and our cakes, and because I had filled it. I didn't really enter anything in, but wait. Okay, yeah, then I go to the recipe scheme, and then I get that when I took that screenshot. Okay, any other questions? Let's see. Any other? Okay, yeah, I'll connect anybody on LinkedIn who wants to connect to me if you're not already. And yeah, so right, I said my blog, my most recent blog post was on attributes. That was a subject that came up, and kind of this, what's the difference with facets, and then e-commerce, and the previous one was taxonomies and data, which also it is kind of relevant to these topics. So, I think I was only sharing one tab. Okay. See anything else?
So just in the interest of time, can I ask one quick question?
Yeah, since somebody else is.
Cool, thank you. So do you have an example, be it through pool party, which actually shows how we can actually get the best out of both worlds, combining taxonomy and the ontology altogether? I know you have completely showcased a few examples there, but I'm just wondering from the developer perspective, from the application perspective, where you want to do reasoning, inferencing, as well as you want to exploit the hierarchical relationship that exists or that comes from the taxonomy side of things. Is there anything along those lines which pool party might have published in the form of webinar or white paper?
Yeah, I don't know. I mean, the degree of inferencing that you can do, OWL type inferencing in a tool like pool party that's basically taxonomy plus ontology is not quite as extensive as you could do in something like Protege. But there's still some, and there's some inferencing, and I'm not even familiar with all of it to really answer that. And I said, and it's not just pool party, it's our competitors in the same kind of taxonomy / ontology space. So I'm not sure if I didn't quite completely answer the question. By the way, I'll just quickly answer why accidental in the title of my book. Well, there are two things. One is the publisher, Information Today Inc. also has other books with that accidental in it. Like it's more in library information science. So they have Accidental Librarian and Accidental Webmaster, and Accidental Data Scientist is in a slightly newer one. But I felt that a lot of people they don't, study taxonomy to become taxonomists. You just like, oh, now I have to make a taxonomy. Now we need a taxonomy. And you have a related skill, and then you find that you need to do it, because that's really more about what it is. So I just want to make sure I answered that before people leave off. I mean, I can stay another 5 minutes or so. So I didn't quite answer any question, that last question fully enough. Okay. All right, well, we're at time now. Thank you for your participation. I hope you got what you had hoped for. You never know. I'm sorry there was a kind of a glitch in the breakout rooms, but we covered everything. And maybe run into you in other parts of this conference later, today or tomorrow. We'll try to drop in on some sessions and maybe on some networking some as well. And
I'll stop the recording and stop the session.
yes.
Great stuff. Have a good rest of the day.
Okay, thank you.